All right, so here we are with lesson 4. Okay, introduction. Manny needs to write an equation in slope-intercept form to represent the linear relationship between x and y in the table shown at the right. So don't forget, slope-intercept form is y equals mx plus b, right? And we are looking for the m and the b, all right, to be able to complete that equation. So describe how he can find the slope m, right? So in a table like this where it's not counting by ones, okay, or it's counting inconsistently, the slope formula a lot of times is the best way to find slope, okay? Now, Manny could observe the fact that this first jump here is by 1, which means that should be our slope, okay? So it looks like our m is going to be -4, all right? Because it goes from 6 to 2, that'd be down 4. However, we could still just use our slope formula, okay? That's sort of a trusted way to always do this. So if I choose two tables from my values from my table, be those two, and I'm going to do y minus y, so -10 minus 2 on top, and then x minus x, so 4 minus 1 on the bottom. And if I do that, I'm going to get -10 minus 2 is -12. 4 minus 1 is 3, and when I divide those, I still get the -4 slope that I thought it was going to be from my observation. Okay, so Manny could observe, okay, or use the formula. Okay, describe how Manny can find the y-intercept. So again, that should be an observation if x equals 0 is in the table. Okay, and in this case, right here, right here, x equals 0 is in the table, which means that number 6 is our b value. Okay, write the equation to represent the relationship. So at this point, again, some of us are struggling a little bit with this. Yesterday, we were finding the slope, we were doing the y-intercept, we weren't really getting to the equation. Remember, in the equation, the y equals and the x are always there. We're simply trying to fill in the blanks. Okay, what are we filling them in with? We're filling them in with the slope and the y-intercept. Okay, so the m always goes with the x, right? So in this case, that was -4. And then the b always goes, it's the constant, okay, so +6. All right, that's sort of our goal, right? And we're going to build off that today, okay? So some problems similar to what we had yesterday. All right, now there's some messy numbers in here. Nothing's counting by ones, so I'm going to have to use the slope formula here for slope. All right, but the one thing I could jump to right away is I could make this observation that I do have x equals 0, which means 6 is my b value. Okay, that's my b right there. All right, however, for the slope formula, I'm going to have to actually calculate, right, because nothing's counted by ones. So I'm going to choose these two coordinates. I'm going to do y minus y, so that's 18.5 minus 12.25. And I'm going to do x minus x on the bottom, so that's going to be 10 minus 5. All right, so, use a calculator here for this. I know we said we want slope to always be a fraction. Well, sometimes when we're doing problems, we can't avoid it, okay? But in this particular case, if I subtract those two, I'll get 6.25 on top. 6 minus 5 is 5 on the bottom, all right? So I don't want to leave it like that. That's kind of messy. So I will actually just calculate that slope, and it ends up being 1.25. So my m value is 1.25. Remember, in my equation, the y equals and the x are always there. I'm trying to fill in the blanks for the m and the b. So I want to 1.25, and I want to make that 6. Okay, that's the ultimate goal, is getting the equation. Okay, to get there, we have to find the m and the b first. All right, number 3. So what I'll notice here in number 3, first of all, is that it's not counting by ones for x, so that means I'm going to have to actually calculate slope, and I don't see x equals 0 in my table anywhere. All right, so that means my b value is not as obvious, but still possible. Okay, so let's do slope first. All right, so it doesn't matter which two coordinates you choose, whichever two you want. I'll choose these two. All right, so I'm going to go ahead and do what? -12 minus -6 over 6 minus 3. Okay, so -12 minus the -6, right? Notice that the minus is still there from the formula, plus the -6 from the number. So that's going to give me a -6 over 3, which ends up giving me an m value of -2. Okay, now what I want to also notice here, when I'm finding my b value is that there is a pattern. It goes from 12 to 9, 9 to 6, 6 to 3. So if my table went one more space over, let's just add a little bar here to make one more space for my table, the next x value would actually be 0, which is going to help me find my y-intercept. So if the x's are going down like that, can I find the pattern for the y's? So this looks like it's going up 6, up 6, up 6. So if it goes up 6 one more time, I'll end up at 0. So my b value here actually ends up being 0. So again, fill in y equals x plus right? So I'm going to go -2 for m and 0 for b. All right, go ahead and pause the video and try these other 3 examples. They're just like those 2. Find your m value, find your b value. Some of them might be in the table, some of them you might have to use patterns to find, and then check back in for your answers. All right, welcome back. Number 2, here we go. Right, so I had to use my formula to find m, 90 minus 50. All right, 4 minus 2, so that gave me an m value of 20. All right, if I follow the pattern here, 8, 6, 4, 2, 0 would be my next one. And it looks like my y values are counting down by 40s, right? So if I count 40 back from 50, I'll be at 10. All right, so my equation ends up being 20x plus 10 for that one. All right, number 4, kind of messy with the fractions, but you have a calculator, so it's okay. All right, I'm going to go ahead and find my m value. 1 1/5 minus 1 over 1. So my m ends up being 1/5. Now in this one, I can actually observe my b value because I have the x equals 0 in the table. So my b value is 1. When I plug each of those in, I get my equation, y equals 1/5 x plus 1. So if you didn't get those, make sure you copy them down, pause the video if you need to. All right, next one, here's a word problem. Luke's family goes to the movies to purchase large popcorn. They're debating whether to purchase any drinks. The table shows the total cost based on the number of drinks. Find the slope and explain what it means. So I'm going to use a formula for that, right? 10 minus 6.25, 1 minus 0, 3.75. That is going to be the cost per drink. Okay, so for each drink I buy, I add 3.75 to the total. The y-intercept is in the table. It's 6.25. And if that's the starting cost, the only thing they purchased so far was the large popcorn. So that must be the cost for the popcorn. And if I write those into an equation, I'll have the 3.75x as the m, which goes with the x value. And then I have the plus 6.25, which is the constant or the starting value. That goes by itself. All right, let's turn the page. All right, at the end of the day, the pizzeria turns off its oven. Okay. The table shows a linear relationship between the temperature of the oven and the first 5 minutes after it was turned off. So clearly the temperature should decrease, right? Okay, when I'm looking, it's counting by ones here. So I could actually just calculate, okay, using the pattern, my m value, right? So that looks like my m is going down 25. So -25 would be my m value. And again, I'm allowed to do that because these are counting by ones, right? So I don't have to use the messy formula if I don't want to. I just need to observe how my y value is changing. Now the b value, okay, is not in my table because there's no 0 minute, okay? But I could follow the pattern and go up 1 and add a 0 minute to my table. And if I did that, I'd have to go up 1 from here, okay, which would be plus 25 to get 450. That would be my b value. And if I plug those into my equation, I'll have y equals -25x plus 450. All right, so -25 is the m, the 450 is the b. What if we have a graph, okay? We can still do all the same things, right? The easiest one is observing the y-intercept, right? I can just look at the graph and find it. Right there it is. All right, it's where the line touches the y-axis. That's my b value. Okay, so anytime we have a graph, it's a little bit easier here. So the b value is 900. Okay. Now my m value is a little trickier. I'm going to have to use a slope triangle here. So it looks like that would be my slope triangle, right? Down 2 over 3. But I got to be careful, right? Because am I actually going down to right 3? It doesn't look like it because these are counting by 100s. So I'm actually going down 200. All right, and then down here, I'm counting by 10s, so I'm going to the right 30. Okay, so when I make my slope -200 over 30, I still want to reduce that, right? So I get 20 over 3. You could leave it like that, or you could write it as a decimal. All right, so I'm going to go negative 20 over 3 for my m. I'm going to plug those into my equation. So y equals, right, negative 20 thirds x, all right, plus 900. Okay. Next one here, Carly wants to buy some fish to keep in her room at a local pet store. Customers can pay $12.50 for a fish tank. That'd be your starting value. And then you can add 20 cents for each fish thereafter. So there's not really any work to do here. Okay, we're just trying to read the text and pick out the important ones, right? So if they're paying $12.50 for a fish tank, you only got to buy one fish tank. All right, so that's my B value. That's my starting value. And then 20 cents for each fish that she wants to purchase. So 0.20 is my M. That's what's going to change. Okay, so I plug those into my equation. Y equals x plus right? And I'm putting the 0.20 in for M. I'm putting the 12.50 in for B. And that would be my equation for how many fish I want to buy. All right, go ahead and pause again. Try those last two word problems on your own. And then come on back to check to see if you got them right. All right, so here we go. Danny was diving for rings at the bottom of the pool. All right, the pool is 8.7 feet below the surface. So below, it's important, right? It's going to give me a negative B value. He grabs a ring and ascends 1.3 feet per second towards the top of the water. So write an equation relationship between Danny, number of seconds, and the depth relative to the surface of the water. So my B value is the negative 8.7 because he's below the surface of the water. He's ascending, which means going up. That's why the 1.3 is positive. And I'm going to plug those in for M and B. Next one here, the Karate Academy charges a monthly membership fee plus additional fee for karate classes. The table shows a linear relationship between the number of karate classes taken and the total cost of the membership fee. Find the error in each statement and rewrite them to make them true. All right, so let's go ahead and look. The cost of each class is $8. That requires you finding the slope. Okay, so if I do 78 minus 60, all right, and then 8 minus 5, I get 18 over 3, which actually turns out to be $6 per class. Okay, so that would be false. All right, my way is correct. The monthly membership fee is $36. So the monthly fee would be the initial value, which has to be the X0 value. So that is not the case here, right? That's the cost of one class. So we actually have to go backwards one in our table, all right, to be able to figure out that value, right? So I have to go back to 0 classes and $30. Okay, so that one was false. Last, a student who attends 30 classes would pay $220. So if I plug everything in that I know, 30 classes times $6 a class is $180. If I add the $30 to that, okay, I get $210. All right, they said $220, so that's false again. Okay. All right, so hopefully you got all those, and we'll see you in class